In this lecture, let's solve some numerical questions on series resonant circuit. So the first example is a coil of resistance 40 ohms and inductance 0.75 Henry connected in series with a capacitor for which the resonant frequency is 55 Hz. If the supply is 250 volt 50 Hz, then find the line current, power factor, power consumed and the voltage across the coil. So it is the RLC series circuit. Where the value of R is given as 40 ohms and the L is 0.75 Henry. The value of capacitance is not given, we have to calculate this value. The supply voltage is 250 volt 50 Hz. And in this question it is given that the resonant frequency is 55 Hz. That means for this circuit the resonant frequency will be 55 Hz. Now we know that the expression of the resonant frequency is 1 upon 2 pi root LC. So we can write resonant frequency, it is 55 given 1 upon 2 pi root L, where the value of L is 0.75 into C. So if we solve this, we'll get the value of capacitance and it will be 11.165 microfarad. After solving this, we will get the value of capacitance. So from the resonant frequency, we have calculated the value of C. But in the circuit, the supply voltage is 250 volt and the supply frequency is 50 Hz. So now at 250 volt 50 Hz supply, we can find the value of XL and XC. So as we know that the XL is equal to 2 pi FL and it is 2 pi into 50 into the L is 0.75. So if we simplify this, we'll get the value as 235.62 ohms. Now the value of XC, it is 1 upon 2 pi FC. So it will be 1 upon 2 pi into 50 into C, that is 11.165 into 10 to the power minus 6, because the microfarad should be converted to the farad. And after solving this, we will get the value as 285.1 ohms. Next is the impedance. The impedance is the square root of R square plus XL minus XC whole square. Here we can see that the value of XC is greater than XL. That means the circuit will be resistive capacitive in nature. So put the values here. R is 40, XL is 235.62 and XC is 285.1 whole square. So after simplification, the value of Z will be 63.63 ohms. So the current of the circuit is voltage upon impedance, and here the voltage is given as 250 and the impedance is 63.63. So the value of the current will be 3.93 ampere. Next is the power factor. We know that the power factor is cos phi, and it is the ratio of resistance to impedance. Here the resistance is 40 and the impedance is 63.63. So after solving this, we will get it as 0.629 leading. The power factor is leading because the nature of the circuit will be capacitive, as we have seen that the capacitive reactance is more than the inductive reactance. So the circuit current will be in the leading position compared to the voltage. So that's why the power factor is leading. Now the power consumed by the circuit. It can be written as I square R or VI cos phi. We can use either of the formula. So if we use I square R, where I is 3.93 whole square and the R is 40. So the power will be 618 watt. And lastly, the voltage across the coil. So the voltage across the coil will be current into impedance of the coil. Here the current is 3.93 and the impedance of the coil means it is a combination of resistance and inductive reactance only. So it will be 40 square plus, we have already calculated the inductive reactance, that is 235.62 whole square. And after solving this, the value of the voltage across the coil will be 939.2 volt. So this is a complete solution. In the question it has been given that the resonance frequency is 55, the resistance and inductance are given. So from the resonance frequency you have calculated the capacitance of the circuit. Now with the supply voltage and supply frequency, first of all we have calculated the inductive reactance and the capacitive reactance. As the supply frequency is less than the resonant frequency, because supply frequency is 50 Hz and the resonant frequency is 55 Hz, and we have already seen that if the frequency is less than the resonant frequency, then the nature of the circuit will be resistive inductive, resistive capacitive. It can be also seen from these values, where the value of XC is greater than XL. Next we have calculated the total impedance of the circuit, and from there we can find the value of the current. Next, the power factor of the circuit, that is the ratio of resistance to impedance, and it is 0.629 leading. The power consumed by the circuit is I square R, so it is 618 watts. And finally, the voltage drop across the coil, that is across the resistive inductive part, it will be 939.2 volts. So this is a complete solution. The second example is, in a series RLC circuit, the resistance is 2 ohms, inductance 2 millihenry, and capacitance 10 microfarad. So find the resonant frequency, quality factor, bandwidth, and the half power frequencies. So the solution. Here R is 2 ohms, L is 2 millihenry, that is 2 into 10 to the power minus 3 Henry, and C is 10 microfarad, that is 10 into 10 to the power minus 6 farad, and it can be written as 10 to the power minus 5 farad. So we know that the resonant frequency formula is 1 upon 2 pi root LC. So put the values of L and C. So it is 2 into 10 to the power minus 3 into 10 to the power minus 5. So after solving this, we'll get the resonant frequency as 1125.4 Hertz. Next is the quality factor. The formula is 1 upon R root L upon C. So here the R is 2, L is 2 into 10 to the power minus 3 upon C, that is 10 to the power minus 5, and the value will be 7.07. Quality factor is unitless, so it is only 7.07. Next is the bandwidth. The bandwidth formula is R upon 2 pi L. So here the R is 2 upon 2 pi into L, where L is 2 into 10 to the power minus 3. So we'll get the value of bandwidth as 159.16 Hertz. The half power frequencies, that is the lower half power frequency and the upper half power frequency. So the lower half power frequency F1, it is Fr minus del F by 2. So it will be 1125.4 minus 159.16 upon 2, and the value will be 1045.82 Hertz. And the upper half power frequency, that is F2, is Fr plus bandwidth upon 2. So it is 1125.4 plus 159.16 upon 2. So after solving, we will get the value as 1204.98 Hertz. So these are the answers. Here in the questions, the values that you have to calculate, it is totally formula based question. So for resonant frequency, we know that the formula of the resonant frequency, we just put the values and we get the value. Quality factor, we also know the formula 1 upon R root L upon C, put the values, and this is the quality factor. The bandwidth, it is R upon 2 pi L, and we will get the value of the bandwidth. The half power frequencies in terms of the resonant frequency and the bandwidth is F1 is equal to Fr minus del F by 2 and F2 is equal to Fr plus del F by 2. So after putting the value in the formula, if we put the values in the formula, we get the value of F1 and F2. So this is a complete solution. The third example is voltage across the resistance, inductance and capacitance connected in series are 3 volt, 4 volt and 5 volt respectively. If the supply frequency is 50 Hz, what is the magnitude of the supply voltage? And also find the resonant frequency of this series RLC circuit. So in the question, in a RLC series circuit, the voltage drop across each elements are given. So voltage drop across the resistance is 3 volt, across inductance it is 4 volt, and across capacitance it is 5 volt. The supply frequency is 50 Hz. We have to find the supply voltage and the resonant frequency. So VR is 3 volt, VL is 4 volt and VC is 5 volt. We know that in a series RLC circuit, the supply voltage is given by VR square plus VL minus VC whole square. So put these values, it will be 3 square plus 4 minus 5 whole square. So that will be square root of 10. So finally the value of supply voltage is 3.162 volt. So this is the supply voltage. In the next part of the question, we have to find the resonant frequency of this circuit. So let's try to find the value of VL upon VC. So it is 4 upon 5. Where the VL is I into XL and VC is equal to I into XC. So it is 0.8. The I are cancelled from numerator and the denominator. So now the XL can be written as 2 pi FL and XC is 1 upon 2 pi FC. This is equal to 0.8. So 2 pi F square into LC is equal to 0.8. Or we can write LC is equal to 0.8 upon 2 pi into F square, where the value of F is given here 50 Hz. So we put the value of frequency 50. So after solving this, we'll get the value as 8.1051 into 10 to the power minus 6. That is the value of L into C. Now the resonant frequency is, we know the formula, FR is equal to 1 upon 2 pi root LC. So in this formula, we will put the value of LC. So it is 2 pi into square root of 8.1051 into 10 to the power minus 6. So finally we'll get the resonant frequency as 55.9 Hz. So this is the resonant frequency for this circuit. This is the solution. Now the fourth example. A series RLC circuit with resistance 250 ohms, inductance 0.6 Henry results in a leading phase angle of 60 degree at a frequency of 50 Hz. So at what frequency will the circuit resonate? So here in the series RLC circuit, the value of R and L are given. So it is the RLC series circuit. The R is given as 250 ohms, L is 0.6 Henry and C is unknown. The supply frequency here is 50 Hz. And it has been given that the phase angle is 60 degree leading. Phase angle means the angle between voltage and current of the circuit. So we know that the current will lead the voltage when the circuit is capacitive in nature. So in a series circuit, if the phase angle is 60 degree leading, that means the capacitive reactance of the circuit is greater than the inductive reactance of the circuit, and the nature of the circuit is resistive capacitive type. Although it is a RLC series circuit, but here the XC will be greater than XL, so the nature of the circuit will be resistive capacitive type. So let's try to find the value of XL first. We know that XL is equal to 2 pi FL. So here it is 2 pi into F, that is the 50, into L, that is 0.6. So the value of the XL will be 188.5 ohms. From impedance triangle of the RLC series circuit, we know that the tan phi can be written as X upon R. Here X means the difference of XL and XC. And as the XC is greater than XL, so here we can write XC minus XL upon R. So it can be written as tan 60 degree. XC is unknown. The value of XL is 188.5 upon R, that is 250, given in the question. So from this relation, if we find the value of XC, then the value of XC will be equal to 621.5 ohms. If we solve this, we will get this value of XC. And now from XC, the XC is equal to 1 upon 2 pi FC, that is 621.5. So from this relation, we can find the value of C as 1 upon 2 pi into F into 621.5, and the value of C will be 5.122 microfarad. Now in this circuit we have to find the resonant frequency, and we know that the resonant frequency is given by 1 upon 2 pi root LC. So it is 1 upon 2 pi, the L is 0.6 and the C is 5.122 into 10 to the power minus 6. The microfarad is changed to the farad. So after solving this, finally we'll get the value of resonant frequency as 81.2 Hz. So this is the resonant frequency of this circuit. Thank you.